Hey everyone, welcome back to the channel. I am Tanya Chu. If you're taking IGCSE Physics Paper 6, you are definitely in the right place. This video is your final boost. So whether you have your exams that is days away or you are cramming last minute, I would definitely help you to walk into that examination hall with confidence. So in this video, we will tackle some common mistakes, some common experiments, and how to plan an experiment like a pro scientist. And of course, we'll describe the experiments with precision as well as accuracy, and most importantly, how to avoid the top mistakes that cost you marks. And plus, we are going to discuss about the graphs, how to plot a nice graph, and the gradient, and how to interpret from the gradient, as well as some suggested safety precaution tips, all packed in this video. So grab a pen. Let's get you ready to ace your IGCSE Physics Paper 6. So this is it. IGCSE Physics Final Boost Paper 6. Now, before I really dive into the discussion on the final boost for your IGCSE Paper 6, I think it's very important for me to remind you on the IGCSE Physics Paper 6 format. Right? First of all, remember the time given is limited. The duration for this paper is only 1 hour. So you have to do it as quick as possible without mistakes, right? And the total marks given for this paper is 40 marks. And this paper is to assess your experimental skills and how you handle the data that are given to you. And of course, your measurement technique. So you have to remember to bring in your CM rule as well as protractor into the examination hall, and how you draw and you interpret your graphs, as well as the last part. This is exciting. You act like a scientist, right? To describe an experiment, to plan an experiment for the future students to conduct, right? So now let's get you ready. First thing about IGCSE Paper 6 is that these are the core skills that you need to master. Right, first thing is that you need to know how to read the skill from the apparatus, and more importantly, reading the skills correctly. Not just reading it, but reading it correctly. And second is about tabulating your data. So how do you tabulate the data? And your graph skills, how you plot a nice graph, how you plot the graph with accuracy, as well as to identify and handling errors. You know, some of the experiments, right, are coming with an error. So how do you identify the error and how do you overcome or minimize the errors that occur, as well as your calculation. So don't forget about your calculator. Use for calculation. So we are going through all these core skills one by one. So let us get started with, oh, and the last part is about planning and describing the experiments. This is the most important part in your IGCSE Physics Paper 6, don't you think so? Because it carries 7 marks. How do you gain that 7 marks easily? So we are going to discuss about that one by one. So let us get started with reading skills correctly. So normally in IGCSE paper 6, they will give you a diagram. Like what I say, this is a written practical. So all the results are being given. So you just need to know how to read the skill. First one, this is an analog ammeter, right? Look at the question. Record the current IS in the circuit as shown in Fig 3.2. I am going to use the past year paper to help you to understand what do I meant by reading skills correctly. My points here. All right, so you look at this question. Okay, reading the scale IS. Look at the needle of the ammeter. This is analog ammeter. It is pointing at this reading. I'm going to highlight this reading. But before you could take this reading, you need to understand the skills of the analog ammeter. What is the smallest division? What is the sensitivity of the analog ammeter? Look at this, okay? These are all 10 mark altogether, right? Between 0 and 0.2. So one scale is red. 0.02. You just say 0.2 divided by 10. So the smaller scale or the sensitivity of this analog ammeter is 0.02 ampere. Do you see that? So now this is 0.0, this is 0.3, and then this is 0.32, this is 0.34. So the reading given here is 0.34, and don't forget the unit in order for you to gain that 1 mark. Now let's try another one. How about that? Yeah. Record the value of the PD. So PD means potential difference. Look at the voltmeter reading across lamp X shown in Fig 3.3. So you refer Fig 3.3. So I look at the scales reading. So these are all scales interval. There are 10 intervals altogether. So the smallest division would be 1 divided by 10, which is 0.1 volt. So this sensitivity of the voltmeter is 0.1 volt. Sensitivity is related to the smaller scale. So the reading here is 1.1 and 1.2. So this is 1.2 volt. Just write down 1.2 volt will do. And what about record the value of the PD Vy across lamp Y shown in Fig 3.4? This is 3.4. Refer to 3.4. Look at the scale. The smallest division is still the same, which is 0.1 because 1 divided by 10 division here. So this is 0.1 volt. The smallest division is 0.1 volt. Smallest division is subjected to the sensitivity of the voltmeter. So this is 1.5 is here. 6, 7, 8, and 9. This is 1.9 volt. Done. So in order for you to get this 1 mark, you have to read the scale correctly. You have to get correct answer for both Vx and Vy. Now, what about reading the digital scale? Reading the digital scale will be easier as compared to the analog scale because you don't have to determine the sensitivity of the apparatus. Look at this question. Record the values of M0, M0, and M5 as shown on the top pen balance in Fig 1.3. So you just take the reading, 3 marks, 30.8, 64.3 gram. Unit already been given. So you can just put in the numbers. That will do. Now, what about thermometer? I want you to bear in mind, right? This is related to thermometer. Thermometer is used to measure the temperature. So for thermometer, always quote the smallest division first before you write down your answer. So let me read the question. Record the room temperature, theta R, shown on the thermometer in Fig 1.2. So I want you to see the smallest division. I start from 0. It doesn't matter which point I want to start with. I start from 0 to make my life easier. So I know that this is separated between pen division. Smallest division will be 1. Right? So 10 minus 0 divided by 10, that's 1. So the smallest division or the sensitivity of this thermometer is 1 degree Celsius. Right, so take the reading here. This is 20, this is 21. Just put 21 degrees Celsius. If the unit is not being given, it is your responsibility to put in the unit. Without the unit, you can't possibly gain mark. So you have to bear that in mind. Now, what about this? Oh, calculate the distance y from the center of Q to the 100 cm end of the ruler. Where is our y? Y is actually here. Right? Y is actually here. First of all, talking about y, right? Like what I say, remember this point? Always quote smallest division. So this is a meter ruler. Meter ruler is the same as your cm ruler. What is the smallest division on your cm ruler? You can look at the ruler right now. The smallest division is 0.1 cm. So I write that down. Smallest division is equal to 0.1 cm. So bear that in mind. Why is this so important? Because before you write down the value of y, look at how you measure the y, the distance y, by using a meter rule that is being drawn for you. Even though they say calculated, but you measure using the meter ruler that is being drawn in the diagram. So the smallest division, right, all the readings, right? We call it as raw data. Raw data is the data or the reading or the measurements which are taken from the apparatus. That is why it is very, very important for you to write down the smallest division or the sensitivity of the apparatus. So the sensitivity of the meter rule is 0.1 cm. Therefore, I have to record my Y value in 1 decimal point. All the raw data must follow the decimal points of the sensitivity or the smaller division of that apparatus. Okay, I will go back to the previous slide to make you understand better. I will explain in thermometer. So give me a while. So I'm going to write down this value here. This is 100 cm. This is 90 cm. Therefore, Y will be 100 minus 90 because we minus, right? So this is 10 cm. So you just put 10.0 cm. What about thermometer? See, thermometer, right? The smallest division or the sensitivity of the thermometer is 1 degree Celsius without the decimal point. Therefore, the reading read by the thermometer, recorded by the thermometer, must be recorded without decimal point. So that is why we're at 21 degrees Celsius, not 21.0 degrees Celsius. Right, but if you face any problem, if you still don't understand what I explained here, do comment below. Right. Important thing that I want you to bear in mind is that each and every time when the question did not mention, did not include the unit, it is your job, your responsibility to include the unit in every answer. Some of the answers, units are included like Y, but data, room temperature, the unit is not being recorded. So it is your responsibility. So you have to check. If the units are being given, it is fine. You just put in numbers, that will do. Now, second is about tabulating data. So you have to write clear headings with units. Headings means the title of your table. So we tabulate our data in table together with their appropriate units. So tabulating data, consistency, we only focus on raw data. The data that is not cooked. Oh, I'm sorry, joking. Raw data means the data or the numbers or the value or the measurements obtained from measuring instrument. That is called raw data. So we look at the consistency. What do I mean by consistency? So first step, right, you know that, oh, I am using apparatus to measure. So I'm using meter rule. So the smallest division of the meter rule or the sensitivity of the meter rule is 0.1 cm. So make sure that all the readings obtained from the meter rule must be recorded with 1 decimal point because 0.1 cm is called 1 decimal point. So all the readings, right, of the length measured by the meter rule must be recorded in 1 decimal point. Now, significant figures are related to calculated data. Okay, as long as you use your calculator to do your calculation, make sure that, let's say, for example, I find area. This is an example, length times width. Let's say the length is 3.5 cm. And let's say the width is maybe 2.1 cm, right? So you look at the length and the width because they are being measured by using meter rule. That is why you have to record that in terms of 1 decimal point. But area is the calculated data because I'm now using my calculator, 3.5 times 2.1. Right, it is 7.35. So the answer given from the calculator is 7.35 cm squared. So in paper 6, whether you put it in cm square or in meter square, it would not affect your mark. So you don't have to worry about that. Unless the question specifically mentioned that you have to denote your area in meter square, then you have to convert to meter square. Else, it is okay to put it in terms of cm square. Right. Now you look at 3.5. Right? So these are called calculated data. So we have to depend on the raw data. So 3.5, 2 significant figures. 2.1 is also 2 significant figures. That is why the area right? Either you put it in terms of two significant figures, which is 7.4 cm square, or one significant figure more than the raw data. It doesn't affect your mark. So I can accept both answers, 7.35 cm square or 7.4 cm square. Both answers are acceptable. Now, let us look at one example from past year. Okay, this is about a student pours 200 cm cube of hot water into the beaker. She records the temperature theta of the hot water at T equal to 0. She immediately starts a stopwatch. She continues recording the temperature at 30-second intervals. Temperature readings are shown in table 2.1. First part, complete the column headings. What do I mean by column heading? It is this part. This is called column heading. The title, right? The symbol together with the appropriate units must be recorded in your column heading. So time. What is time being measured? Time is being measured in seconds. So just put slash second slash the unit. Theta. Theta is called temperature. Temperature. What is the unit of temperature? This is called degrees Celsius. Right? And then complete the first column of table 2.1. Remember, they said that time 30-second interval, right? So she continues to record. So maybe this one you put 0, right? Depends on the question. Depends on the question, right? Start from 0 or 30-second. Okay, after that 30, right? 60, 90, 120, 150, and 180. Right? These are all, we call it as first column. Done. Now, the third one is about your graph, right? Your graph, the scale, right? Most of the students, they face difficulties in determining the scales. The scales part, you have to, like, it is hard to give you the specific scale because sometimes the graph can be started from origin. Sometimes you need not start at origin, right? And then the scales thing, you have to make sure the gap between all the scales are uniform. So don't just put, okay, I start from 20 and then this one become 30, suddenly this is 40. Could you see the gap between the scale? So this is 10 cm gap, okay, or maybe 10 number. So this is, or maybe this is 50, okay, this is 20. So that is not a uniform scale. So you have to make sure that the distance or the difference between all the scales are uniform, right? And then you have to label both axes together with their appropriate units. You have to label your y-axis, x-axis together with their appropriate units, right? 1 mark will be given to the labeling the axis. And make sure that every point on the table here must be plotted, right? Must be must be move to the graph. You get what I'm trying to say? Right? Plot all the points correctly on the graph. And then, because all these points, the examiner will definitely check your point, whether your points are being plotted correctly. 1 point wrong, I'm sorry, the whole mark will be deducted for the plotting part. Plotting part, 1 mark. And if the question asks you to calculate the gradient, so you have to show the working by drawing the triangle. It's not just simply any triangle. The triangle must occupy at least half of your straight line, right? In order to get a more accurate value or accurate readings. Right, so let me show you some examples here. So the first example, I have already filled in the heading, right? I put in cm, the unit, time in second, period in second, and period square is in second square. So the question is that you have to plot the graph. They have already mentioned, question mentioned clearly. So your t square must be on the y-axis, cannot be on the x-axis. If you put it on the x-axis, I'm sorry, axis, you will lose mark for axis. Yeah, and x, okay, this is about x and t square. This is how I plot. So axis, 1 mark. Could you see that? Axis, to correct physical symbol together with their appropriate units, right? Look at my scale. You do not need to start your axis at origin. So do not start from 0. If you want you want your graph to be, you want all your points to be more spread out, instead of all the points are too close together, because if your scales are very very small, then all your points will be too close to each other, and then the calculation will be very very inaccurate. So that is why it's very very important for you to determine your scale correctly, but never ever use odd scale, right? So could you see that my scale, odd scale, not to say odd number, right? The weird scale, like maybe 3, 6, right? Something like that, or 7, 14, 21. These scales are quite odd. Why? Because it is very hard to get your readings, right? You depend on your readings actually. So you look at the smallest division and the largest division, right? You just find the difference between the two readings, so the smallest reading and the largest reading, and then you try, right, to find the most suitable scale. So some students say, how I know which scale is suitable? By doing a lot of practices, right? Because the graph, right, the height, the width of the graph given are changing all the time. So I cannot give you the fixed scale, right? As long as you make sure, first thing you do when you look at the graph paper given, you calculate the number of boxes, right? Could you see that this graph? Okay, look at the vertical part. I have one big box. Yeah, I use different color to show you. Two big boxes. Okay, 3, 4, and okay, 5. Okay, roughly about 5 big boxes, right? So make sure that your points, the scattering of your points, must occupy at least 2.5, because vertical, you have 5 big boxes. Make sure that your points occupy at least 2.5 big boxes. Look at my point. My point occupy 1, 2, 3, almost 3, right? Or more than half. That will do. Look at the x-axis. X-axis is easier because 30, 35, 40, 45, and 50, right? If you want to start from 10, then you can start from 10. You don't want, you can always start from 30, 25 is up to you, right? I start from 10, right? So, or horizontal, you could see that, look at the horizontal, the width of the graph, 1, 2, 3, 4, 5. 5 big boxes are given. So you have to make sure that your points occupy at least half of 5, which is also 2.5, right? So you have to make sure that, right, as long as the scattering of your points occur between, like, half of the big, okay, vertical boxes and half of the horizontal boxes, the length, right, of the graph, you are safe. We call that as a good graph. Yeah. Now, another example that I want to give you, you look at this one, plot a graph of L on the y-axis. They have already labeled against M. On the x-axis, start your axis at origin. So you have no choice. They ask you to start from origin. If you are asked to start from origin, then we have to start from the origin. So if you have a problem in determining your best fit is a straight line that passes through most of the points, right? If you have a problem in determining your best fit, let's say this is your x-axis, you add up all the values of the x-axis and divide it by the number, right? 1, 2, 3, 4, 5. 5 numbers altogether divided by 5. Get one average coordinate for x coordinate, and for y coordinate, add out all the y values and divide it by 5 number, right? So number of, okay, all these experiment repeated, right? And then divided by 5, get an average value for your y-axis. So when you have one average coordinate of x and y, so make sure that, okay, your straight line graph pass through that point. That point is called the average, right? Or centroid. A centroid is a point where the straight line graph must pass through. A straight line must pass through. Okay? So number 4 is identifying and handling your errors. For example, there are 4 types of big errors here. One is called random error. The other one is called systematic error, zero error, and the most common one is called parallax error. So we are going to look into these errors one by one. Let us look at random error. Random, the word says it all. Random, it comes from, I don't know where is the specific direction of this error to occur. It could be coming from everywhere, any direction. Right? So it is an error that causes all your measurements to sometimes be larger, sometimes smaller than the actual reading. For example, yeah, parallax error. Let me show you. Sometimes when we are in the lab, we are conducting experiment. I use ruler. Is that okay with you? So I have a ruler. I am measuring, okay, maybe the length of this pen. So I place this pen on my ruler and I am supposed to look, right? My eye position supposed to be perpendicular to the scale on the meter rule, right? Just imagine this is meter rule. I don't have meter rule at home. So just imagine that this is a meter rule. My eye must be perpendicular to the scale on the meter rule. But sometimes because in the lab, I have my friends. So we're talking, right? Chit-chatting. Oh, yeah. Oh, yes. Okay. So sometimes my head is tilting a bit to the left and I got my reading, right? Then my eye position is not directly perpendicular to the scale on the meter rule. Sometimes, right, I just adjust my head a little bit. Okay. I just turn to the right a little bit. So I measure in different direction. Could you see due to the tilting angle of my head, right? My eye position could be sway away from 90 degrees. So that could be the cause of the parallax error, right? That could be the cause of the random error. So parallax error is one of the main cause of the random error because we chit chat, and I don't know whether my head is 90 degrees, right? Or my eye position is 90 degrees to the scale on a meter rule or stopwatch. You have a stopwatch. Sometimes, okay, I have already released the pendulum. I'm supposed to press it, okay, after one or two complete oscillation, but sometimes I press it too fast, sometimes I press it too slow, right? That could be the cause of the random error. Now, the other error is called systematic error. Systematic error, system, right? Mostly is caused by the measuring apparatus. So the apparatus given, right? It is an error that causes all your measurements to be larger or all your measurements to be smaller than the actual value. Example of the systematic error is the zero error. Sometimes the meter rule in our lab is 100 years old, maybe more than 100 years old, 200 years old. Okay, joking, okay? So, at the end of the meter rule, sometimes, okay, most of the time, they are being worn off. So the zero mark is not visible anymore. But doesn't mean that we need to throw the meter rule away, right? That's a waste. This meter rule can still be used. It's just that you don't start your reading, you don't start your measurement at 0 cm because 0 cm is invisible, right? It's not visible anymore. So you might want to start with 10 cm. But if you start with 10 cm, you get your reading and you forgot to minus that 10 cm because you're supposed to start from 0 cm, remember? So if you take your reading, let's say, okay, I draw a very nice meter rule. I hope that this is nice enough. Okay, this is a meter rule. And due to this meter rule is quite old, quite ancient, you start from 10 cm. Right, and then you place your object here. Right, so the length of the object, let's say this is 19 cm. So this length of the object supposed to be 19 cm minus 10 cm, which is 9 cm. But due to you forgot to minus that 10 cm, you will record your value as 19 cm, which is larger than the actual length of the object. That is what we call systematic error. And sometimes, especially when we are using the analog ammeter or analog voltmeter, right? So the needle supposed to be at the zero mark, but sometimes due to that, right, the needle is below the zero or above the zero. So that is called systematic error or micrometer screw gauge. So when you main scale, the zero mark on the main scale supposed to be coincide or form a horizontal line with the timbre scale, the zero mark on the timbre scale. But due to the zero error, sometimes they don't meet. Zero doesn't meet the zero on the timbre scale. So that is called systematic error. Now, okay, of course, we have errors. Instruments have errors. Humans have errors. Experimenters have errors as well. So I would like to give you some suggested improvements. So we need to improve our experiment in order for our result to be more reliable, right? So the suggested improvements are for better accuracy and reliability of our measurement. So the measurements, right? If you want to talk about the measurements, maybe instead of using measuring cylinder that you measure, right? This measuring cylinder, let's say, yeah, big scale. So the water is just here. So you could use a measuring cylinder with a smaller scale division. That would be more accurate, right? Or you take your measurement. These are just suggested improvement. You could write this. Take measurements at eye level to avoid parallax error. And before you use analog emitter, analog digital, or your micrometer, meter rule, check for zero error. For meter rule, look at the zero mark. Is it visible? Right? And use set square, right? To make sure that your meter rule is vertical. Set square, the function of a set square is just to make sure ruler is vertical. For electricity, you might want to suggest this if you conduct experiment on electricity, right? Make sure that you open the switch after each measurement. Now, of course, there's a reason why we do that, because we don't want our connecting LEDs, connecting wires to be overheated. Right, we don't want the resistance of the wire to increase drastically. That is why switch is open. Let the circuit cool down first for 1 or 2 seconds, then you close the switch. Right? Or we could use variable resistor or rheostat to control or to vary the current in the circuit. If you want if you want a small current, then you increase the resistance of the variable resistor by your glider. You just glide it. And you might want to suggest this as well. So it depends on the question. If the analog emitter and the analog voltmeters are given, instead of using instead of using analog, you could suggest maybe use digital emitter because they are more sensitive. Or use digital voltmeter instead of analog voltmeter. Right? And sometimes when we use digital emitter or digital voltmeter, the readings on the digital meters are fluctuating most of the time. Sometimes give us this value before I could record the value changes to other values. So that is why, okay, you need to tighten all the connection to minimize the fluctuation due to the circuit that is not being tightened up. So the readings, okay, because the wire barely touch each other. So that is why you tighten a little bit to minimize the fluctuations of your digital meters. Or oscillation. Okay, when you talk about oscillations, right? Sometimes, like what I told you just now, random error. Sometimes I press the stopwatch a little bit faster. Sometimes I press the stopwatch a little bit slower, right? Instead of using the stopwatch to measure the time, we could use light gates, which are being connected to data logger. So light gates, it's like a sensor. So you have two light gates. When the pendulum bob, for example, oscillation of the pendulum bob, pass through first light gate, it will start the timer. Pass through a second light gate, it will stop the timer. So to measure the time. Light gates are used to measure the time. And right, for oscillation, you might want to take multiple number of oscillation and divide by number of oscillations for period. For example, instead of, okay, if the question asks you to find, okay, one complete oscillation, which is period, right? So you displace it to, okay, let's say you displace it to point A, right? This is point B, this is point C. One complete oscillation is that A to B to C, back to B, back to A. You could do that, but that will give you a lot, right? Random errors, right, on the period measurement, because when you first release, right, the pendulum bob, there's a large air resistance because the speed is, right, depending on the angle. right? And the angle of displacement might not be consistent as long as you make sure that the angle of this is what we call angle. Okay, you have to displace it at a certain angle. As long as the angle is small enough, right, we could ignore the air resistance. Right now, so you divide by the number of oscillations for period, because the best way to measure the period or could calculate the period is that you let go of this pendulum, let it swing freely for 2 to 3 complete swings first before you start your stopwatch. Then take 1, 2, 3, 4, 5, stop your stopwatch. That's it. And then take the total time divided by 5 times, because I took 5 number of oscillation divided by 5, that give you your period. Or you could use a retort stand to make sure that the pendulum is at fixed position. Instead of you just holding it, sometimes you hold it with different angles, right? And another thing, if you want your oscillation, the measurement of period to be as accurate as possible, make sure that the angle of oscillation is smaller than 10 degrees to minimize the air resistance. And when we calculate the period, we ignore the angle of oscillation. So that is why if the angles are very small, we could ignore it. But if the angle is very large or large, air resistance acting on the pendulum bob plus the angle of oscillation cannot be ignored. That is why make sure that the angle of oscillation or angle of pendulum bob being displaced is small enough. If possible, make sure that this is smaller than 10 degrees. For light, right? So for light, for a better improvement, you might want to conduct the experiment in a dark room, right? Or you use white screen at the back for the sharper image detection. Or you make sure that the light and the screen are aligned. You know, sometimes when they're not aligned, it is very hard for you to see the image form on the screen, right? And use your sharp pencil and protractor for accurate ray tracing. This is ray. Now, for temperature, if you are measuring the temperature of a liquid, make sure that a stirrer being inserted in, use stirrer. Why? Because when the liquid is being heated out by maybe a heater, right? So this is the whole liquid here inside the beaker. So you might place the heater here. So only this part, okay? Liquid, the temperature of the liquid is not uniform distributed. So that is why if you want it to be uniform, the heat to be uniform distributed throughout the whole liquid, you use a stirrer to stir the whole liquid, right? Only valid to liquid. And okay, you might want to insulate the apparatus, the beaker, the container, to reduce the heat loss to the surrounding, right? So the general suggestions, right? If you have lack of ideas, they ask you to suggest something, you really blank, you don't know what to write, you could write this, right? To help you. Maybe you say repeat the readings and find the average. Or just say avoid parallax error, make sure that the eye level is perpendicular or 90 degrees to the scale of the measuring instrument, right? One thing that you have to bear in mind, reliability of the experiment is equal to repeatability. If you repeat more times, right, and you find the average, your result will be more reliable. Now, okay, I would like to suggest safety precautions as well, right? Why we need this safety precaution? To prevent injury or damage to the apparatus or to the lab. So, suggested safety precaution for electricity. First one, when you're dealing with electricity, maybe you want to focus on using low voltage, right? AC supply. The AC supply given to you or DC supply given to you can measure voltage up to maximum of 12 volt, right? So you might want to use a low voltage to prevent electric shock when you touch any of the electrical circuit. And you could say that maybe switch off the power supply when you're not taking any measurement to avoid overheating of the circuit. And maybe avoid touching bare wires and metals when electricity flow in them. What is bare wire? Bare wire is the wire without insulator. And that's called bare wire, right? And you might want to use rheostat or variable resistor to prevent your wires from being overheated. and which will increase the overall resistance of the circuit, right? Now, heating, right? Maybe for a heating object, right? You use the heat resistant gloves to handle hot object. You don't touch it with your bare hand because it could cause injury to you, right? Or you allow the hot apparatus to cool down first before you touch them. Yeah. And laser box or ray box, you be careful. Do not look directly into the box because laser light has a very, very strong illumination. The power is quite large, right? It could damage your eyes. So beware with that. Heavy objects, sometimes you're hanging slotted masses, right? You might want to place a cushion or the bucket of sand below the hanging object, just in case the string snap, object drop to the floor, right? And from the five calculations, right? Sometimes in paper six, basically you don't need to memorize equations. Most of the time formulas are given, but sometimes all you need to do is just to rearrange the formula, right? Cross multiply or division, multiplication, the basic of mathematics you have to know, right? And beware with the unit conversion. Sometimes they give you in cm and they want it to be in meter, so you need to know how to convert from cm to meter, maybe from meter to millimeter, etc. Right? And then don't just leave it blank like that and show your answer. Examiners would want to see your calculation, your workings. Show step by step working. They give you a free space there to let you show your working. So write your working step by step. And your final answer, right? We are going to look at the correct significant figures as well as the correct unit. Doesn't matter if you don't put it in the standard unit or SI unit. Doesn't matter. You can put it in cm, you can put it in gram, unless the question stated that you have to put in a certain unit. Right, the number of correct significant figures actually depending on the data that you use for your calculation. Let's say A is equal to B divided by C. B has two significant figures, C has three significant figures. So for A, you can choose to put 2 to 3 significant figures, right? Or A is equal to B over C, or B multiplies by C. B has three significant figures, C has three significant figures. You can choose to put A as three significant figures or four significant figures. One significant figure higher than the raw data, significant figures of the raw data. Now, most important part is here. Okay, let us look at most important part that give you the 7 marks, the last question of IGCSE Physics Paper 6, suggested questions on planning experiment. Are you ready? Right, let us get started. First one. Okay, maybe you are asked to determine the density of irregular shaped object. So the expected answer, what we expect you to write is that, first of all, you need to know how to calculate density because density cannot be measured. Density is equal to mass over volume. So you need to tell us how to measure mass, how to measure volume. We want to see this. I want to see how to measure mass, how to measure your volume, and how to calculate the density together with the formula. Now, okay, this is my suggested answer. Are you excited? Okay, don't just draw it. You have to label it, right? So let's say prepare, right? This is a measuring cylinder. Don't just draw your diagram. And diagram doesn't mean that you have to draw a very nice diagram, 3D diagrams. No, 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 no such thing. 2D will be enough, right? So this is measuring cylinder. Make sure that you write down. Just label it. This is water. And this is the same measuring cylinder. I don't know why it becomes shrink, right? This is the same measuring cylinder. And then this is maybe a rock. They will tell you irregular shaped object. Okay, so what are you supposed to write down is that, okay, first of all, okay, we want to see this. Set out the apparatus or as shown in the diagram, right? First thing, fill in water into measuring cylinder. Take its initial reading. Second, place rock into measuring cylinder. Take its final reading. And then, oh, okay, I forgot to measure the mass of the rock. So before you fill in, you're supposed to measure the mass first. Okay, wait. Okay, so this one I put 2. This is the third one. Can I put number 1 here? Okay, number 1, measure mass of rock by using um, electronic balance, I call it. Electronic balance. Okay, and then number 4, volume of rock equals final reading, okay, minus initial reading, or final volume minus initial volume, not a problem. And then density can be calculated by mass of rock. If you want to put in unit, it's in gram, because electronic balance will give you the unit in gram over, okay, volume of rock in cm cube. That's it. Right. So the safety precaution is that you use the measuring cylinder with the correct scale. Right. And then make sure that if you want to repeat your experiment, make sure that the rock that you retrieve from the water inside the measuring cylinder must be dry out first before you place it on the electronic balance. That's all. Right. Now, second might be determining the relationship between the length and period of pendulum. So expected answer, we want to know length, how you measure the length. What are the apparatus? What is the apparatus that you measure the length? And then, okay, period. Period, we want to know, okay, this one you might want to use meter rule. Period, you might want to use, period must be calculated. So when I need to see the time. Yeah, measurement. So the time measurement, you might want to use stopwatch. And then, okay, right. Okay, period can be calculated. And yeah, this is my suggested answer. So I have a retort stand, right? So that I can hang my pendulum bob, right? So I just label this retort stand. Okay, and then this is my protractor. Remember I told you about protractor? Make sure that you displace, because I want to make sure that the angle of displacement of my pendulum bob is the same all the time, right? And then this is the bob, pendulum bob. This is the string, length of the string, right? So the first one you might want to say length of string is measured by using meter rule. And then after that, okay, set up apparatus as shown in diagram. And then, okay, displace pendulum at maybe 8 degrees because protractor is used to measure the angle. And then let pendulum swings for 2 complete swings. And then after that, start stopwatch. Okay, measure the time for 10 oscillations or 10 swings by using digital stopwatch or just stopwatch, right? And then period can be calculated. Or you can say repeat the experiment, right? By time taken for 10 oscillations per 10. Right? And then number 7, repeat. Last part is always repetition. Repeat the experiment with different lengths of string. Right. Now, safety precaution is that, right? You might want to say switch off the aircon, switch off the fan, because pendulum bob is quite small, so it could be affected by the wind when you conduct the experiment, right? So that's all. Now, the third one, measure resistance of wire. So expected answer, we would want to see, we don't really use ohm meter in the lab, but we measure the resistance by using voltmeter. We want to see you use voltmeter. We want to see you use ammeter, and we want to see how you calculate the resistance. Normally, the formula of the resistance will be given, right? And then length of the wire, because this is the wire, length of the wire. How do you measure? Right? These are all the expected answer that we would want to see, right? This is my suggested answer. This is my circuit, right? So I call this as maybe power supply. This is ammeter. Ammeter to take the value of the current. This is a connecting LED. This is ruler, meter rule. So if you are asked to measure the resistance of a wire, make sure that you place your wire, tape it on top of the meter rule. Right? It is very easy to measure the length. It is very easy to make sure that the length is always constant. Right? This is resistant wire. This is my voltmeter. And as a safety precaution, I use variable resistor. That's it. So you could say that, set up the apparatus as shown in the diagram. Second, you might want to say wire of 100 cm or 1 meter is placed on meter rule, and then power supply is switched on. Okay, if you want to put a switch here, that would be even better. If you want to put a switch here, okay, a switch here is also okay, right? Because one of the safety precaution is that, but if the switch is not given, you just disconnect, switch off the power supply. That will do, right? Power supply is switched on, and then readings on ammeter, which is I, and voltmeter, which is V, are taken. And then resistance is calculated by V over I. Right? So maybe you could say that repeat. After that, repeat the experiment with different lengths. Right, your table, right, you have to put, okay, this is like table, maybe your length, put in terms of cm. This is called heading, right? I put a unit. This is ammeter reading. V, this is a voltmeter reading. And R, right, unit. This is how your table looks like. Right, suggested improvement, maybe you could say that switch off the power supply, right, after each measurement is taken to avoid overheating of the connecting LEDs that will increase the overall resistance, right? Or, okay, use a rheostat to control the amount of current, because we are using resistant wire. Sometimes too much of a current will cause the resistant wire to be melted. So you have to be careful with this. Okay, now number 4, determining focal length of a convex lens, right? How do you find your focal length? You measure right? How do you find? And how do you determine? So how you draw your convex lens. That's what we expect to see. Now, my suggested answer, I have different convex lens, but of course, I need to measure the thickness of the lens first, right? This is a lens. I put two wooden blocks here and I place 30 cm rule because in the lab we have 30 cm rule, we have 50 cm rule, and we have 100 cm rule, right? Place it to measure the thickness of the lens. So these are the apparatus set out here. I need to have a light bulb illumination, right? But the light bulb needs power supply or need the cell, just connect to the cell, doesn't matter. And okay, lens in front of the light bulb and the screen can be adjusted. So the distance, okay, this will be your meter rule here. Okay, meter rule is used to measure U. U is called object distance, and V is called image distance. So you just shift your screen, yeah, forward, backward until you obtain the clearest image, right? So the method is like this. Set out the apparatus as shown in the diagram, U and V. So in this past year question, one of the past year questions actually, so the U and V are already explained in the question. So I can use the symbol. U means object distance. V means image distance. U and V are measured using meter rule. I didn't draw it so that I have to explain. So the light bulb is switched on, the screen is moving back and forth to obtain the sharpest image. And always repeat the experiment with different thicknesses of the lens. So that is why measuring the thickness of the lens is very important. And thickness of the lens can be measured by placing two wooden blocks on the two sides of the lens as shown in the diagram. So whenever I draw, I don't have to explain that much. Could you see that? So drawing diagram is very important. But don't just draw a diagram, you have to draw a labeled diagram. That is super duper important. Right, this is your table, right? The table, could you see my heading, U slash the unit, V slash the unit, and the thickness of the lens cannot be in cm, must be in millimeter. So it is quite thin. Now, number 5, maybe investigating resistance of different lengths of wire, similar to the previous experiment that I explained, right? So you have to tell us, how do you find the resistance? How do you measure the length, right? These are all expected answer. Right, so suggested answer, they gave me power supply. So I just need to connect to ammeter, variable resistor, remember, to control the amount of the current that flowing through the circuit, and resistor wire just placed on top of the meter rule. So you can see the length will be the same all the time, right? And the voltmeter connected across the two ends of the resistant wire. Right, okay. Now, number 6 is a bending distance of a ruler when loaded. Okay, we would want to see ruler, okay, or meter ruler to measure the distance. You have one ruler to bend, the other ruler is to measure the distance, right? And then you need to have load. How do you measure the load? Okay. Now, this is my suggested answer. I have a table, I have a G clamp, right? I have a meter rule, or we call it as a wood strip, doesn't matter. This is 1 meter, right? It's the length is similar to the length of the meter rule. And I have slotted mass here. This is my meter rule, but meter rule cannot stand by itself. It has to be clamped to the retort stand. Remember set square? I use set square to make sure that my meter rule is vertical. Right, so when you place a slotted mass, this wood strip will bend. So the bending distance is the difference between the two readings on the meter rule. Right, so the procedure, I say set out the apparatus as shown in the diagram. The strip of wood is clamped by using the G clamp at one end so that it's secure, right? It is being secure, not moving. And you take initial reading of the height of the strip by using meter rule. And slotted mass is placed at the other end of the strip, right? So the strip will bend, so the final height of the strip, right, is taken. Then you can measure the bending distance. So the bending distance, here, bending distance is equal to final height, whichever is larger, okay, or initial height minus final height, depending on how you clamp your meter rule. Right? And then you repeat your experiment by using strips, plastic. Oh, this is one of the past year questions. Using strips of plastic, steel, and aluminum. That's all. Okay, so my table is like this. Material of the strip, I suggested wood, plastic, steel, and aluminum. And the bending distance, H/cm. Now they asked to suggest a conclusion. Because I'm the planner, you cannot give the conclusion. So got to say that, okay, whenever you have conducted this experiment, you just compare the material, right, of the strip being made of with their bending distances. The strip that bends the most with the same load is most bending. That's all. Right, number 7, stretching length of rubber band with different weaves. One of the passive questions as well, right? So this is related to Hooke's law, remember? So stretching length, you need to have your length, and then you need to talk about extension, and then of course you need to put a load, F equals kx, but k is not important because we are not discussing Hooke's law here. Yeah? So let us see, this is my suggested answer. We have retort stand, and then there's a hook there. And then we have a rubber band with a hook here to hang your load. I have a pointer. I put a pointer because sometimes the distance between the rubber band and the ruler is a bit distance. So I want to make sure that I get the reading instead of I just depend on the air to give me the reading. So I put a pointer there. But the pointer, the mass of the pointer must not be significant. Yeah. Meter rule, use another retort clamp to clamp it. Right, so this is how you're supposed to do it. Set out the apparatus as shown in the diagram, right? And then place a load. Okay, I just write it here. Set up apparatus as shown. Okay, measure initial length of rubber band by using meter rule. And then place a load of maybe 10 grams on hook. Oh, this is not log, this is 10 gram. How come it look like a log here? Okay, 10 gram on hook. All right, and then measure the final length of rubber band by using meter rule. One of the improvement is that I use pointer. Is that okay? Now, okay. Is this called stretching length? Okay, stretching length is equal to final length minus initial length. That's all. And then you could say that repeat experiment with rubber bands of different widths. That's it. Now, number 8, different colors affect rate of cooling. This is true. So I want to see your colors. What colors you want to use? Are you going to use red, yellow, green, purple, right? You have to talk about the colors. So we will expect to see the colors. We will expect to see water. We will expect to, like, you use stopwatch, right, to measure, and then the thermometer. So these are the apparatus that you have to write. So let us look at mine. So suggested answer, this is my thermometer. Like what I told you just now, I said that if this is about liquid, then you have to use a stirrer. And you pour in hot water to stir to make sure that the heat distributed evenly. And I'm using red color metal container. So look at my answer. One or two passive questions actually. So the method is that I wrote measure 50 ml of hot water using measuring cylinder, and then you pour hot water into the red color metal container, and then you take the initial temperature of the hot water by using thermometer, and the temperature of the water is taken every 30 seconds. Don't say 5 minutes, right? Don't use minute, use second, right? Experiment is repeated with yellow, blue, green, purple colored metal container. So the stirrer is one of the safety precaution is to make sure the distribution of heat is consistent throughout the whole liquid. Now, this is my table. Since this is a past question, why not I just give you the table as well? So the time slash the unit and the temperature of the metal container, degrees Celsius. Put different colors, red, blue, green, and yellow. So I did from 0 second to 150 second. Right, conclusion that I have to make because I'm not the one that conduct the experiment. I'm just a planner. So I give you some clue here. So you look at your table. The greatest drop in the temperature shows that it is the best radiator of heat. Right, the best absorber of heat is also the best radiator of heat. It will absorb the heat and it will radiate faster and give out to the surrounding. Now, number nine, okay, maybe the relationship between power supply to the heater and the time taken to heat the water. So the power supply to the heater, you have to bear this in mind. Heater come with power rating. So it's stated on the heater itself, right? Power, but, okay, so, or you can calculate your power if you want by using IV, the current value and the voltmeter reading, the voltage. And the time, I want to see you use stopwatch. That's all, right? So suggested answer is that I didn't put in, I just draw in the diagram without labeling. I couldn't possibly gain the mark, right? So I'm going to write down, this is rheostat. This is power supply. Switch, ammeter, okay, water, heater. This is voltmeter. And this is thermometer here. And these are connecting LEDs, okay? So suggested, wow. Okay, first of all, right, experiment. Okay, I just write my answer at the back here. So the methods would be set up apparatus as shown in diagram. Power, oh, I say pour. Okay, sorry. Okay, you might want to say pour. Okay, look at the diagram again. I want to pour in water first, right? Okay, pour maybe 100 cm3. You can suggest of water or measure first before you pour. Okay, sorry. Sometimes you have to plan your experiment, okay? Not easy to plan, okay? Measure 100 cm3 of water by using measuring cylinder and then pour water into beaker. Did I state that this is beaker? No. And then I say close the switch. And switch on power supplied of 8 volt. I just put a value there and then take readings from voltmeter and ammeter. And then tell us how to calculate the power. Power can be calculated by voltmeter. Okay. Oh, this one. Put a comma, put capital V here, put a comma, put I here. Right? I times V. And then number 7, take readings on thermometer for every 30 seconds until not you need, I'm so sorry, until 180 seconds. And then after that, yeah, always repeat, right? Experiment must be repeated. Always repeat the experiment by adjusting rheostat for different values of I and V. So you see your power will affect, right? This question is about power affect the time taken. This is it. Now, number 10, determine the specific heat capacity of a metal, right? So specific heat capacity, you have to recall after your paper 4, E equal to mc delta T. So E is called the heat or the thermal energy. M is the mass of the metal. C is called specific heat capacity. And delta T is the change in temperature. So the expected answer, we want to see you put thermometer. We want to see you put time, stopwatch, mass, how you measure mass, right? How you calculate the heat, right? Look at my answer here. So this is a metal block. Wow, my heater look like a spring. It's not a spring, don't worry. I wasn't born to be an artist. I'm very bad in drawing. So metal, this is the metal block. This is the thermometer. And this is a power supply. And then if you want safety precaution, put a rheostat here, right? Rheostat. Power come with the power rating. Is that okay? Heater with power rating. And insulating material is to make sure we minimize the heat that lost to the surrounding. So, okay, my suggested answer, so I have to write this one by one. Okay, set up, oh, measure the mass, because I need the mass, remember? Specific heat capacity, mass of metal block is measured by electronic balance. And then what else do I need? Okay, set out the apparatus. Set up apparatus as shown on number 3. What else? Power supply switch on. Yeah, power supply of maybe 10 volt is switch on for maybe 3 minutes because I want to heat out the metal, right? And then time is measured by stopwatch. And then energy, okay, or heat can be calculated by power rating of heater multiplies by time, right? So time is 3 minutes. You have to change it to 180 seconds. Is that okay? And then after that, what else do I need? Okay. I didn't say that I measure the initial, initial temperature, right? I'm so sorry. Let me erase this one. The number I'll just put in here, set out the apparatus, power supply. Okay, before that, third, initial temperature of block, okay, is measured by thermometer. So make sure that you plan your experiment first. You draw first before you write down your answer, right? So that your answer will be like more systematic instead of you just do it like me. So, sometimes we need to cancel this, cancel that. That would be very, very messy, right? Plan first what you want to write, right? Number 4, power supply switch on and then time, right, is measured. Okay, heat can be calculated, right? And then you could say that final temperature of block is taken, because I have already stated that this is measured by thermometer. So change in temperature of block, which is delta T, is equal to final temperature minus initial temperature. So number 9, specific heat capacity. Can be calculated by PT. Okay, I put here as P. This is T over M delta T. Mass of the metal block, M. Just put it simple, right? So you can calculate. And then if you want it to be more accurate, repeat the experiment by, okay, changing time of heating, right? Why we want to repeat? Because we want to minus the heat that lost to the surrounding, right? That's it, right? Finally, I want you to remember one thing here, right? Before I erase everything here, right? So I want you to remember that this is the final exam tips that I want to give you. Make sure that you read the questions carefully. Understand the question first. Don't rush to give the answer. Right? And then please underline the key terms and don't make careless mistake on your graph because you don't have a lot of time. Right? Make sure that all the points are being plotted correctly and accurately. Right? And check for the units, for the significant figures, as well as decimal points. Right? Write your answer as neatly as possible. Right? And that is all, yeah, for your final boost of your IGCSE Physics paper 6, right? Remember, this paper is not about memorizing, okay? This paper is about thinking like a scientist, and you have to trust your understanding. Be clear in your writing. And if you found this useful, give it a like, share it with your friends, and hit the subscribe button. I would love to send you a full PDF of this just for that. How about that? And I wish you all the best in your exam. And as always, I will see you in my next video. Bye.